The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and welcome to today's webinar entitled Pull and Kanban Kanban Systems. I'm Scott Shive, Director of Marketing Communications for AME, and I'll be your moderator today. Today's presenter is Don Guile, principal with the firm of Synchronous Management. Don has nearly 50 years of experience in manufacturing. His pioneering work includes capacity-based lot sizing techniques for changeover-intensive resources, make-to-order Kanban for the non-repetitive job shop, and virtual pull for complex purchasing, manufacturing, and distribution environments. He's the author of Pull Kanban Training Program for the NIST Manufacturing Extension Partnerships, and he's also an author of Pull Kanban Systems Training for the Lean Enterprise Institute. He is a frequent speaker for AME, SME, CSCMP, and APICS, and I think you'll really enjoy today's presentation. Before we start, just a couple of housekeeping items. As many of you have heard before, you'll be in listen-only mode throughout the webinar. You'll see that you are muted on your attendee panel on the right side of your screen. If you have any questions during the webinar, please type them into your question area in the attendee panel and click on Submit. We will review the questions at the end of today's presentation and answer as many as we can. And when you log off today, please check your email inbox, and it will be an invitation and link to fill out a short webinar attendee survey. Please take a few minutes to complete the survey today, as your feedback is very important. And Don has also graciously agreed to provide a PDF of his presentation. We will be sending that along with a recorded link for the webinar replay to each of you within 48 hours of today's presentation. So without further ado, I'm pleased to introduce Don Guile, who will present Pull Kanban Systems. Take it away, Don.
Thank you, Scott. I appreciate it. I appreciate the opportunity to speak with you folks. And you're taking time out of your busy day to participate in this. I know it's probably lunchtime for some of you. So I appreciate it, and we have a lot of material to cover, and let's get going. I thought what I'd like to do today, instead of just going through sort of standard, Kanban material, is to focus on a little bit on some of the issues and problems that people run into in implementing. I suspect most of you have some form of Kanban going, and they have run into some of the issues we want to talk about, and we'll talk about how to address those. So with that in mind, I'd like to give you a word of caution here. There is an old saying I remember hearing years ago that I would advise you to keep in mind if you're going to implement full systems. And of course, this saying makes a lot more sense if you hear it out loud. So I'll read it for you. It says, never undertake vast changes with half-assed ideas. Okay, so you can interpret that however you want to. But the point I want to make is, when you implement Pull and Kanban, it's a significant change in the way you do business. Just to begin with a little bit of a distinction between push and pull systems, you've probably heard the terms before. Push is a method of scheduling which is based on deriving dates from lead time offsets, from finished product demand, customer orders, or forecast. And it's usually derived through some computer system such as material requirements planning or enterprise resource planning, something like that. If you are scheduling items to dates today, those are not on Kanban. Those are not full items by definition. Pull production is different. In full production, requirements are signaled by your customer. So the downstream activity signals their needs to upstream activities, as opposed to date offsetting. And of course, the Kanban or Kanban itself is merely the signaling device. It's the signal that you send to authorize procurement or production. So with that in mind, let's talk about the agenda here. We're going to go through some key issues that I think a lot of people face, at least in my experience, most people face, and we'll talk about how to deal with some of those. We'll do a review of what I'll call repetitive Kanban systems, where you have an inventory of something and you replenish it with a Kanban signal. But I also want to talk a little bit about non-repetitive pull systems, where you're not carrying on-hand inventory of items, and then talk about the impact of pull on some of your other systems, like requirements planning and performance measurements and so on. So here are the issues we see people running into all the time. One is making sure that you get supermarkets right-sized. And now a lot of people will tell you, pick a number, start it, and then adjust it based on the results you see. And that's one way to approach it. However, if you quantify your supermarkets, if they're data-driven, it gives you a whole level, additional level of control and understanding of your production flow. So making sure you get the math right is really important. It's also important to make sure that the logistics you use are sustainable. If you have thousands of items on Kanban, if you have large batches, multiple Kanban batches, you're probably going to have trouble maintaining a system using Kanban cards. So we want to make sure the logistics are sustainable, or if you have frequent changes to demand or processes, you're adding cards or removing cards, it can become a nightmare. It can break down. You also want to make sure you have a way to deal with demand that is not Kanban. It's either spike demand for Kanban items or demand for non-Kanban items. Okay? You have to have a way to incorporate those into your scheduling process. You need to make sure you interface your pull system with other systems. You may have work orders, for example. You may have traceability, none of which will keep you from implementing pull, but they need to be taken into account. And then, of course, the all-important changing performance measures. Everybody runs into this, moving from the traditional cost accounting measures to measures of flow and waste. So I want to talk about some of these issues as we go through this today. Okay? Now, you all may have some forms of pull system in place. You may have, vendor-managed inventory or two-bin systems or Kanban cards. You may use reorder point or min-max. The point I want to make with these, and you may all have some form of these, is that they are, in one form or another, pull systems because they are consumption and replenishment based. So if you look at min-max, you're going to replenish inventory to the maximum when it drops to the minimum. That's a form of pull system. So these are merely the various ways of executing the pull system itself. So why are we doing it? One of the things I want to help define is why you want to implement pull in the first place. What defines success? Well, one is, of course, improved service. That means higher fill rates to your customers, and it means fewer shortages. You also want to do this with reduced inventories, which means shorter lead times, less non-value added activity, and so on. You want to simplify things. We already have very complex scheduling systems. We want to simplify the scheduling process so there's less overtime, less expedited, less scheduling effort required. And you should see some pretty significant reductions in the time to do the scheduling, for example, on the order perhaps of 70, 80, 90% reductions. And then really important, I think, is why we want to quantify supermarkets is so you get predictable results. You can quantify the financial impacts of flow and of waste so that if things don't happen as you predicted, you know where to go to find out why. So predictable results, quantifying, doing the financial benefit, financial justification, and so on, also helps you to gain support if you can project the financial benefit and then actually achieve it. Okay? So let's start by talking a little bit about repetitive Kanban systems, and then we'll get into non-repetitive and then some of the other impacts. Okay? So here's the structure. Let's suppose we have what we'll call a value stream loop here. And this I lifted from Learning to See by Rother and Shook. It's from Ackley Stamping. And it's 2 spot weld operations and 2 assembly operations happening in sequence. So what we do in a repetitive Kanban system is we put a supermarket in place, and that's our the lean symbol for a supermarket, which is an inventory of a specific item. And then as customers order that item from us, and it could be an external customer, could be an internal customer, we send it to them. And then to get the inventory replenished, we send a Kanban back to the value stream to tell them we've used some material, we want to replenish it. And that's really the essence of what we call a repetitive, or in lean they call a type A pull system. And in this type A pull system, what drives replenishment essentially is a drop in the on-hand inventory. So when the inventory you have on it drops, you signal replenishment for that inventory. Supermarkets. Let's talk a little bit about where we want to put supermarkets, okay? At least strategically. Obviously, you want to get them as close to the point of use as possible physically, but strategically, If you understand your lead times to your value streams, and you understand the lead times required in the marketplace in order for you to gain market share, you can compare the two. And anywhere, any products for which your supply lead time is greater than the market required lead time, you're going to have to carry some inventory somewhere, or you won't be able to meet that market lead time. So that's the primary thing you want to look at, is how long does it take me to get it versus what is the customer demand. And keep in mind, lumpy demand can extend lead times. If my demand is 100 a day, and then all of a sudden one day I have demand for 400, that could be a 4-day lead time. So we need to keep that in mind also. Another consideration in where to locate supermarkets strategically is where demand is highly repetitive, where it's very predictable. And the reason for this, even though demand is predictable, the reason for this is that it enables you essentially to bank capacity into items that are highly repetitive, items that you know you're going to sell, so that when you do get demand for non-Kanban items, or you do get monthly demand, you can deal with it. You can produce it without it disrupting the service on those highly repetitive items. So that's another thing you want to look at is, items that are highly repetitive are good candidates. And how you define repetitive is different in every company. Okay? But essentially, it's where you don't have continuous flow. I think they say in lean. Okay? So let's talk about sizing. I think it's really important to get the math right. So I want to go through a little bit on sizing supermarkets. There's a symbol for a supermarket. Every supermarket has a supplier and can have a number of customers. First thing, and the folks in Lean, we very conveniently divided this into 3 sections, which works out very nicely for this. First thing we need to understand is what is our average customer demand. Now we can get this from a forecast, from sales and marketing. We can get it from a forecast we come up with based on history. We can get it from gross requirements out of our requirements planning system. But you do need some forecasted rate of demand in order to calculate how many Kanbans you need for an item. If we know our supplier's lead time and we know our average customer demand, we can calculate our average demand during the replenishment lead time. So if our average demand is 100 a day and the customer has a 3-day lead time, this value is 300. In other words, when our inventory drops to 300, we order some more, assuming demand is 100 a day every day and doesn't vary, and assuming the lead time is 3 days and doesn't vary. If this looks suspiciously like order point to you as I go through this, it's exactly what it is. Order point and Kanban, or order point is a variation, as I explained earlier, of Kanban or full. Now, we have the value, 300. Now, that assumes demand is 100 a day every day and doesn't vary. And, of course, we know demand does vary. So we need to understand consumption patterns, shipment patterns or consumption patterns for component material, because we need to make sure we have enough inventory to cover the spikes in demand, or at least some percentage of those spikes. And that's called safety stock. So let's assume that we want a 98% service level. And let's just assume for the purpose of the discussion that means I need 400 units of safety stock. I'm not going to go through the calculation of that because we don't have the data here to do that. So let's assume our safety stock is 400. Now what this means is when our demand, our inventory in the supermarket drops to 700, I order some more from my supplier. The question then becomes, how many do I order? And make sure, please make sure you include this in your supermarket calculations, because most of the formulas out there don't. They assume you're already running very small batches, and you may not be. So I need to understand then how frequently my supplier can replenish. So for example, my supplier may be shipping to me from 4 states away, or from 1,000 miles away, let's say. And it takes 3 days for the truck to get here. But a truck may leave every day. So there'll always be 1 or 2 or 3 trucks on the road. Well, if a truck leaves every day, that means I could order some every day and have them put it on the truck. So in this case, if my daily demand is 100 and I could order some every day, my average order quantity would be 100. So what we've done here in this example is we have calculated that on this item, we need no more than 800 units on hand and on order and on the road coming in from the supplier in order to have a 98% service level. Okay, so the nature of pull is you're capping the inventory and you don't order anymore until you use some. Now, The example I've just given you is purchased material coming from an outside supplier. If you produce the material in-house, you take a slightly different approach to batching. You need to calculate, incidentally, while I'm here, the safety stock and the average demand during lead time, you may have seen that before. It's called order point in order point theory. Okay? So if you're producing internally, you need to calculate the batch size. You don't negotiate it with a vendor. So you need to look at, on a resource, this is done by resource, what's the available time per day on the resource. If I schedule 24 hours a day, the most I'm going to get is 24 hours a day of work off that resource. Now, I know I may schedule it 24 hours a day, but I lose some time to downtime, so I need to subtract that. Let's suppose that's 4 hours a day. Well, that leaves me 20 hours a day to do what? To run product and to change over to run product. To run product and to change over to run product. So the next thing I want to understand is how many hours a day do I need to spend running product? But that's simply a matter of taking all the items I run on that resource, their daily demands, times their cycle times, and add them up. And that tells me out of the 20 hours a day I have available on this particular machine, I need to run product 16 hours a day. If I subtract, that means I have 4 hours a day left to do changeovers. Next thing I want to know is how long would it take me to go through the changeovers on all these items that run on this machine. Just add them up. If I want to go just the changeovers, I've already accounted for the cycle time. So just add up all the changeovers. Okay? Let's suppose they add up to 12 hours on these items. Well, if I have 4 hours a day available to do changeovers, and it takes me 12 hours to get through all my changeovers, just divide it out. That means that I can set up and run some of everything every 3 days. So EPEI is every part, every interval, and what we've just done is calculate that interval on this particular machine. So if I have an item I run on this machine, the demand is 10 a day, the batch size will be 30. If the demand is 1,000 a day, the batch size will be 3,000. So if you have changeovers anywhere in your processes, don't forget to include every part, every interval, or EPEI in your calculations of supermarkets. It's a very important piece of it. A little bit more about the batch size. So I'm going to stay here talking about the batch size up here. Okay. We know that we know customer demand fluctuates. It varies. Okay. So what we do in a push system is we take that customer demand, we run it through a computer system, and it generates a schedule for our production operations. And the result of that is any spikes in customer demand or any troughs in customer demand propagate back into our supply chain, so the demand on the supply chain is lumpy. Okay? So what do we do about that? Because, we're trying to schedule these dates, so what do? Well, we'll put in a pull system. We'll put in some Kanban. Otherwise, we have these overloads that we either have to produce early, or we produce them late, or we increase our capacity to handle the spikes. And none of those are acceptable in most cases, okay? All right? So what do? Well, let's implement some Kanban. We know customer demand is lumpy, so we'll have a finished goods supermarket. We'll put that in place, and we'll let that absorb the fluctuations. So when customers order a lot of goods, the inventory will go down. When they order very few, the inventory will stay higher. So what does that do to the signals that go back to my supplier? Well, if I use this many and I send Kanbans back to replenish that many, and at some other point I use fewer and send Kanbans back to replenish fewer, that lumpy demand just still propagates back into my supply chain. And it's very difficult to manage and lean out a supply chain where the demand is lumpy and unpredictable. So be careful of the concept of ship one, make one, ship two, make two, ship 30, make 30. Okay? That nonlinear demand will still disrupt flow even with Kanban systems. We need to have a way to level things out in our supply chain. We need to have a way to keep that demand from propagating, that lumpiness from propagating into our supply chain. And so that nonlinear demand no longer disrupts our flow. That's called Hijunka. That's the whole purpose of Hijunka, is to do that, is to level things out. Now, how level and how granular you can make the mix is derived from the EPEI in your pacemaker loop, in your final assembly and finishing processes. And you want those batches to be as small as possible because it puts a smooth demand on your supply chain, and it means you're using a little bit of all your raw materials every day or more frequently anyway. And that puts a nice smooth demand all the way back to your supply chain. So EPEI is important because it quantifies the impact of changeovers and cycle times and downtime on your inventory, okay? But it's also important because it helps you to get the smoothest possible demand on your value streams and on your supply chain, okay? Safety stock. Let's talk about the middle portion here, the yellow portion up here, safety stock. It's just merely statistical calculation. We calculate the standard deviation of your in your demand patterns. So I could have two items, for example, that have, the standard deviation gives you the deviation from the average. I could have two items with the same average demand, but one has a higher variation in demand. We'll have a higher standard deviation. And you just use a table of a normal distribution to tell you, for example, if you want 98% fill rates, then you're going to need 2.05 standard deviations of safety stock in that supermarket, okay? That's in addition to demand during the lead time and in addition to the order quantity. It's only one of the three elements, okay? And then, of course, also keep in mind, and one of the reasons it's important to quantify supermarkets is where you have short-term fluctuations in demand, safety stock is a great tool. It will compensate for those, give you enough inventory to cover those short-term spikes within lead time. But you may have longer-term variations in demand. You may have seasonality, or you may have new product introduction, or you may be producing styled products. In those cases, you need to recalculate the supermarkets periodically. They need to be reset. So keep that in mind, that in every company we've ever seen, supermarkets do have to be recalculated periodically. Periodically, most of the time, in our experience, means monthly. There are exceptions, but that's generally what most people that we've seen who are successful will do. They do it monthly. Okay? And, of course, then the third element, the lead time, pretty straightforward. It's queue times and wait times, transportation times, those kinds of things. What you will find is if you locate supermarkets in the right location, locate them strategically, if you quantify the supermarkets in the fashion we just discussed, the lead time from one supermarket to the next for an item becomes much more stable and much more predictable. So you don't have to worry as much about the lead time fluctuating if you do a good job with locating and sizing the supermarkets. Okay? So let's talk a little bit about examples of some pull systems. And what you use for the pull mechanism will vary depending on, number one, is my supplier close by or far away? It's going to be difficult to transfer Kanban cards if my supplier is in another state. It's also going to be a function of do I have a lot of items I'm dealing with, very infrequent changes, very stable business. If I have a lot of items, large batches, a lot of changes, that will affect what I can use for logistics. So let's start with very few items, customer, supplier close together. You can just use empty space. And here you see a shelf that is empty, that contains, when it's full, contains some of these items. These products are produced over here, and they're used over here on the other side of the aisle. And their signal back here to fill that shelf is merely the empty space. Because they're so close together, the outbound and the inbound locations are the same. Okay? I think what's interesting, however, just very quickly about this, is if you want a visual control, here's a visual for you. You see this? That's dust, okay? So that tells you something else in addition to what needs to be made, okay? It's going to raise the question, why isn't it made yet, okay? You might use first in, first out. Here's a machine that cycles through parts in a specific sequence, and then whatever comes in next is what gets worked on next. Very, very simple, okay? Here's a real simple assembly schedule. These, I don't know if you can tell what these are looking at the screen, but I'll tell you, they are piano tops. You can see grand pianos and smaller pianos here. And this is pulled at the beginning of each day and loaded with the piano tops. What you're looking at is the assembly schedule. Now, is it perfect mix? Well, no, because you can see there's some batching here. These are all the same, and then these are all the same here. So someday, as they reduce their batches, you'll probably see a better mix of piano tops in this rack. Now, if my supplier and customer are a little further apart, I can't physically see their inventory necessarily, or I have more items, then I might use the container instead of the empty space, or what we call a Kanban square. And here's an example of a container system. These are components for building switches for power tools. They're built on the reverse side of this rack is where they're assembled, and then they're used over here on the other side of the operation to build the switches. And each color is a different part number of subassembly. So as assembly needs a part, they'll pull the bin out of the rack and take it to assembly, and then when the bin is empty, they bring it back to the rack and they put it in the rack facing the other direction. Okay? So as long as the people in the back of the rack see containers facing them, they keep building. If they see no empty containers, they stop building. So this gives them the mix of what to make, and it gives them the authorization to make it. Now, let's make it a little more complicated, okay, where maybe my supplier is in another building on the same location, and it just doesn't make sense to use containers because you have to dedicate containers to specific part numbers. So now we use cards that represent empty containers, or what people generally think of as a Kanban card, okay? And the Kanban card can be simple, just with a part number on it. It can be barcoded, you know, with all kinds of information on it. It takes whatever form works for you, but it certainly at least has to have the part number that you want to make and probably the quantity that it authorizes, at least those two, okay? So here's a quick example. These are steel coils in a company that makes bottle caps. So here's their inventory of steel coils. They implemented a simple card, card-driven Kanban system, and you can see there's the part number on the Kanban on the coil. As a coil is used by the press area, that card is taken off and sent to purchasing. Purchasing faxes it to the steel supplier and then sends the card down to the receiving department. And then when the coil comes in, the receiving department reattaches the Kanban to the coil and sends it to the point of use. And I thought you might want to see what point of use looks like after. These two pictures, this one and this one, are taken from the same location. And you can see what it's done to their inventory to implement the full system. Remember, one of the issues is, one of the keys to success is it giving me better service with less inventory? Two of the keys to success. We may use the cards as FIFO. These are cards going back to an operation. Each one of those is a Kanban card for an item that is making a metal brass nail that goes in the middle of a battery. And all that's doing, it's a FIFO link. And the cards come in and they get added from the top down, okay? And, or from the bottom up, I'm sorry, from the bottom up. And then as they're satisfied, they're taken off from the bottom up, okay? And then new cards come and get added from the top down. These are all the same part number, and it authorizes their production of those little nails that go in the battery. So it's a first in, first out, basically, using cards instead of using containers. Now, we get into bigger batches. We're going, where the batch is more than one Kanban. We need to start accumulating Kanbans when we signal. So here's some component parts for printer chassis. These are stamped metal parts addressed in the storage area. And the Kanban cards, you can see there are Kanban cards on the outside of these bins. These Kanban cards, as the bins are emptied, are sent back to a board at the press area that stamps out more parts. And each of these columns is a part number. It's a specific one of those items that you saw on the other photograph. They calculate for each item an order point, which is the red cards, and the order quantity, EPEI, which is the green cards. And the pink cards here are the Kanban cards themselves. Okay, so you can see on this item, for example, the supermarket is full, all the Kanban cards are with material. And you can see on this item, we're almost out. We have two Kanbans on the board, there's only one left. So we know we have less than a container left in the supermarket. Now the beauty of this is it gives you the priorities very clearly. Okay? It's very clear the first priority here is going to be either this item right here or this item right here. Okay? Pick one and run it, and then run the other one. Okay? So you can see the priorities here because basically what you have is a Gantt chart, a bar chart of the inventory. Now this is accumulating Kanbans, where the batch size is more than one Kanban. You have to accumulate them. It's called a trigger board or Kanban accumulator of some kind. These systems get very complicated, okay? So you have to be very careful with them. Here's a Hijunka box. Again, cards come in and they get distributed Monday through Friday, so we're leveling out production for each item. So here's an item apparently they run only on Monday, Wednesday, and Friday. Here's an item they run every day. And this is their attempt to do level loading with Hijunka. Now the card system works fine to a point, okay? It can very quickly turn into one of these. And I have no idea by looking at this what to make. I suspect none of you do either. So my point is a manual system can become so complicated it's no longer visual. And we have to be careful of that. This system is just not usable. It may reflect reality, but it's not usable. Okay? So maybe we go with some sort of electronic approach, okay, electronic system. Could be as simple as this, a disposable Kanban. So I have material at the user. The user empties the bin, pulls the Kanban, wands it, discards the Kanban, it prints out a new Kanban at the supplier, they fill the container and send it back. So this is kind of a hybrid where a manual Kanban is used, but it's generated electronically, okay? And it works for the application for these folks. Their batch size is one Kanban, which is one of the things that makes it work. There's no accumulator. So once it's printed, they run in the order in which they come off the printer. Okay? Maybe it's a reorder report. You can see here's just a simple reorder or min-max report where we have the trigger or the order point. We have a lot size. It's telling us how many to make. Or if we have excess inventory, it's telling us what to remove from work in process. Okay. Or there are some orders they could potentially even cancel. So it's basically a trigger report or a reorder report. Okay. Here's another example of electronic, we call it the virtual pull system, and let me zoom in on it. It'll be easier for you to see. And this is producing batteries, packaging batteries for Sam's Club. You can see there are AA's, AAA's, C's and D's. Each one of these, they've calculated how big the supermarket needs to be. So these are days. So this first supermarket, if it were full, would have 17 days worth of material in it. This item would have, what is that, 14 days worth of material. So this warehouse is probably, distribution center is probably physically closer to the factory than the other one. And that's why you need more inventory to cover long transportation time. The way to read this is, red means we have inventory in the distribution center to cover that day. Yellow means it's on a truck, it's on the way. White means we don't have any and we're not making any. All right. And incidentally, it would be interesting to see, this is the door to the men's room and the door to the ladies' room. So this is projected on the wall in the cell that makes the product. Okay. So you can see when they started this is day one. AA's and AAA's don't look too bad, but we're in big trouble on C's and D's. Okay. It's because this photograph was taken in September of that year, which is hurricane season, which is when the demand for C's and D's goes through the roof. And they got caught with their pants down. But it's very clear now what their priorities are. And this thing is maintained by it's online, it's live, so as material gets shipped, this thing gets updated. As material goes in and gets produced and goes into the distribution center, this also is updated. So the cell leader has very clear visual view of all her customers' needs. And she decides what to make. There is no scheduler in this cell. The scheduling job is to make sure the numbers are right. The job of the cell leader is to make sure that she's making the right material. So if you want to know why something didn't get made, you don't talk to scheduling, you talk to the person making it. Okay? So it's what we call, we've seen more of the application, this kind of virtual pull approach as people deal with some of those complexity problems that we talked about earlier. Okay. Okay, so that's kind of a little bit of repetitive pull. What how do you calculate supermarkets? Making sure how small could you make the batches so you're level loading as much as possible. And what are some examples of the appropriate signal to use depending on your environment? One one that I showed you where they did the Kanban for the steel coils, they also did a manual Kanban system in another area where they did have some batching. And what they found was because of seasonality in the business they're in, they were constantly adding and taking cards out of the system and had to design the system to make that as easy as possible. So we want to make sure that the system is sustainable, because if it isn't, it won't sustain. People just won't use it. Okay. All right, a little bit about non-repetitive pull systems. Remember this, our Type A pull system. Okay. Now, this is for items on which we're going to carry supermarkets, but most operations also have some items that are made to order. In fact, some operations are all totally strictly made to order. So we need a way to deal with this make-to-order demand in addition to the Kanban demand, okay? Because they likely go on the same resources or go through the same value streams, right? So we need a way to pull those as well, okay? You're not going to pull them to an inventory, but it's still possible to pull them. And this is called a Type B as in boy, pull system. And here's what we do. We put a gate, if you will, at the beginning of the value stream, okay? So we're not just going to push things into the value stream, even if we have a Kanban. We're not going to put it in the value stream unless they can actually work on it. So we need to establish in the value stream just how much work do they need out there to maintain the flow. Was in a company a while back that has 70 operators, and they had 1,200 orders on the shop floor to be worked on, which means since an operator can work on only one order at a time, at any point in time they have 1,130 orders out there that are not being worked on. Well, you don't need 1,200 orders to keep 70 operators busy. You need much less than that. So one of the things you want to do is bring your work in process down. We'll talk about that in a minute. So what we do is find that level of work in process. That's the minimum we need to maintain the flow. Then when something comes out of the value stream, either to satisfy a Kanban requirement or a customer order, make-to-order requirement, and the work in process drops, then we release more work into the value stream. So that's another form of pull, okay? It's called a Type B pull system. And you may also have heard the terms constant work in process or conWIP. Same thing. The conWIP is a form of this Type B pull system. This pull system is driven not by a drop in on-hand inventory. It's driven by a drop in work in process inventory. By a drop in work in process inventory. Okay? Now when you look at this, everything you make is either lends itself to a Kanban system. I can have some inventory replenish what I use, or it doesn't. It's either one or the other. And what you've seen here is it's possible to put everything that you make on some form of pull system. Type A, Type B, or a combination of the two. Okay? You can pull anything through your production operation. All right? I also want to thank Mike Rother and John Shook for letting me steal part of the value stream map here to illustrate this for Acme Stampings. Okay, so first thing is, how do I know what the value stream is? And when you get into more of a make-to-order environment, you have a lot of shared resources. It becomes much more difficult to define value streams. You don't have the dedicated resources you might have in a mass production type operation. Now, what John and Mike talk about is, lay out your products on the y-axis, lay out your production processes on the x-axis, and then just indicate for each item what processes it goes through, and you'll see families emerge. They kind of magically emerge from this. Okay, I could treat left and right-hand steering brackets the same. They go through the same value stream. Okay? The real world is never that simple, of course. I could have hundreds or thousands of items, and I could have hundreds of machines. How the heck am I going to define value streams in a case like that? Well, one of the things you can do, just as an example, is what if we took this and instead of just putting X's in there, we showed volume. In other words, how many units per week of item 1 have to go through machine 1, and how many units per week of item 2 have to go through machine 2, and 7, and 16, and so on. It's just a different view of the matrix. But what it does do is it makes certain common flows fairly apparent to begin with. You can see these items, these 6 items, generally are most of the load on the machines that they go through, and they generally follow the same patterns, okay? And likewise, these items. So we've identified potentially 3 families or 3 value streams. Now remember, a lot of shared resources, but that's okay. We'll show you how to control that, okay? So first thing is to define the value streams, and a load matrix is a good way to do it, all right? Next thing is, for each of these value streams, start bringing the width down, okay? Because we want to get rid of that non-value added time in the value stream. Probably not going to hurt if you start with a 1/3 reduction in that width, okay? Now, people will scream, wait a minute, the dates say we need to start something, but we're not scheduling the dates anymore. We're scheduling the flow. The dates will give you the sequence of release. The availability of capacity will tell you when to release, okay? Bring the width down, release less work than comes out, temporarily increase capacity to sort of bring the work in process down, okay? And then when something comes out of the value stream, something goes in. Sounds real simple. It's never that simple, okay? But that's the general idea, right? You need to have a way. The reason that, I say it's not simple, you need to have a way to identify where are the bottlenecks. Where do I put resources to keep the flow going, okay? How do I know what the rates are of release, and how do I set the priority of release? So let me give a couple of examples. This is the flow of a large molded item that actually gets bolted onto the legs of offshore oil rigs, provides flotation. So one of these items is the side of a truck, okay? Each of these little envelopes contains a card, a couple of cards. One is a Kanban card for the item that's being made, and then the little yellow card is the mold. So the key thing here is the mold. They want to keep track of where all the molds are, which ones are available to mold more product, and which ones already are in process and have product in them. And the cards show where they are in process, all the way from prepping to filling, injection molding, testing, grinding, and then, of course, excess inventory. I think they were shipping about 10 a week of these items. And when they started, they had 60 or 80 in process in various locations. So what they did was they said, okay, we're only going to allow the shop floor to have so many of these envelopes. And nothing gets released without an envelope. So unless an envelope gets emptied, and when it's emptied, the mold card goes back on the board, the envelope goes back to production control. They pick the next item to be produced that the mold's available for, and put it in the prep to fill column and release it. So they limit, and they can see where things are piled up. You can see, obviously, we have a lot of work piled up. Actually, most of the work this is all grinding. Most of the work is piled up with grinding, okay? So you can see where the bottlenecks are. This was at startup. The grinding, this inventory is all gone now. They're operating on about 20 units of work in process. Here's another type B pull system in a machine shop. These colors you see, there's one color and there's another. Those are cells, machining cells, turning, milling, grinding, and so on. And each of these packages is a production order. It has all the information to make the job, and they limit the number of packages they allow on this board to 40 packets. And what signals putting something else on the board is when a job gets done, the packet is empty, and the packet's sent back to production control to put more in process. And they use this board to decide where to put their people in a 15-minute morning meeting every day. Okay, and then a little more complicated system, type B pull system, and you can see a lot of shared. These are their value streams. These are their major machining areas, and you can see that there are a lot of areas like sheet metal shop that really is shared among value streams. But this tells them where things are piled up, and it tells them where they are in each family, each value stream, to their target work in process inventory. This company brought their work in process, they were doing 200 orders a week. They brought the width down from 2,200 orders in process to 1,000 orders in process, and cut their lead time by 60%, thereabout, something, and still get the same volume of output, but going through much, much faster. Fewer expediting and scheduling problems. Okay? So that's a type B pull system, to give you an idea of that. So let's wrap up the next 5 minutes to talk about the impact on other systems. That remember, I told you this is a big change, and one of the biggest changes is going to be how does it work with other systems? Okay. Now, It does change roles and responsibilities a bit. You know, your value stream manager, it's a supervisor, really are responsible for monitoring, is it working, right? Are people following it? Production control tends to be the ones who calculate supermarket sizes and how many Kanbans or full signals you need. Purchasing, raw material forecasting, that sort of thing, negotiating blanket orders, and then it's the process owners who actually tell the supplier what to bring in. Okay, they're responsible for the day-to-day activity. And of course, you need material logistics involved for replenishing supermarkets, setting up and replenishing point-of-use stores, and so on. And if you're going to, you do need to have information systems folks involved because you need data to size supermarkets to calculate EPEI. And if you want to automate the system using a virtual pool that I showed you at the battery company, you need their help in doing that. Okay, so it involves a lot of people, a lot of different areas in a slightly different way from what they're traditionally used to doing. Okay. A little bit about MRP. You know, MRP basically you're doing this is material requirements planning. It's scheduling, backdate scheduling, and basically you do some sales operations planning and then develop a long-term 3 to 5 years. Master production scheduling. What do we think we're going to need to make over the next several months, whatever. Run it through a program that then goes down, explodes your bill of materials and tells you what you need to buy, what you need to make, and do you have the capacity? So what do I need to make, what do I need to buy, and then do I have the capacity to do it? And if I don't have the capacity, you feed that big into your master schedule and adjust it to until it fits. Pool replaces this part of it. You still need S&OP. You still need master production scheduling, and you probably still need to run material requirements planning. You just don't want to make to the material output of MRP. You want to make to Kanban. Okay? Remember, you need the MRP. You may need MRP for work orders, for traceability. Okay? And you need it for gross requirements to give you rates for forecasts for sizing supermarkets. So Kanban works very nicely with MRP as long as you're only using MRP for planning and not scheduling and using Pool for scheduling. One last thing, and we'll wrap up, and that's metrics. Okay, you're probably all familiar with some of these metrics. High utilization. Get 100% utilization out of your resources because you think it keeps your costs down. And of course, what happens is when you do that, since not every resource is a bottleneck, you end up increasing inventory and losing flexibility. Okay, or high efficiency, where I take my changeover cost and I amortize that cost over the batch size so that the larger batch I run, the lower my unit cost was, okay? All right, or overhead absorption, where you amortize overhead costs over your volume produced in a time period. So you're making things the customer doesn't really need, but your overhead absorption looks really good, okay? One of my favorites, overall equipment effectiveness, OEE, okay? You have to be careful with OEE. You want to, it's a good tool, but you want to make sure it's basically trying to get high utilization out of resources. Excuse me. Make sure you're using on critical resources, not just anywhere, because you don't want to focus away from those most critical areas. So OEE is okay, but be careful with it. Okay. And then of course on-time performance. Driving. Did I meet the dates on lower level items? Obviously I want to meet my customers' required dates, but for component items, it's not the date that drives things. It's the actual availability of material for the customer, okay, the internal customer. So be very careful. I've seen companies use Kanban system to generate a work order. Then they put a date on the work order and measure whether or not they met that date. Totally wrong. The question is not did you meet the date on the work order. The question is, did you have the material when you needed it? Two different things. So be very careful with date performance for component items. For finished goods items that are going to the customer, it's fine. But for lower level items, be very careful with date performance. I think you want to be looking at things like, am I meeting tact time? In other words, there's a rate of output that was needed. Did I get it? Okay? Did I get the rate at which I should have been producing? By department, by value stream, by resource. Am I getting more of my goods on time? Either the customer's need date, external customer need date, or availability in a supermarket. What really matters is the supermarket, did it run out? Okay? If the supermarket never runs out, you're 100% on time. Am I shortening the lead time to the value stream? Is the total material time in plant getting shorter? And is the productivity of the value stream getting better? In other words, are getting more output versus the units of input, okay? And the unit of input could be raw material cost, it could be labor, all right? It could be energy, but am I getting more output, electricity and so on? I could be getting more output. Am I getting more output per unit of input? These are measures of flow and waste, okay? And one of the, if not the biggest stumbling block in implementing pull effectively and implementing change, culture change effectively, is changing metrics, as we're so comfortable and so used to these the old traditional accounting metrics. So I would advise you, this is one of the things that if you're implementing pull, you will have to address at some point, okay? So to wrap it up, the keys here, okay? I think you need to have a champion of this in your operation who has the vision, who understands pull, who understands what it's going to do for you, and the authority to make it happen. Okay? I can actually get it done. Let me be clear what I mean by authority. Authority means the ability to hire and fire people and sign checks. That's what authority means. Okay? That's not an internal lean facilitator. Okay? It's somebody who actually has the authority to get it done. You need to make sure that your supermarkets and work in process levels are data-driven. If you do that, you have another tool to help you improve your processes, because you can see, if you can calculate supermarket, you ought to be able to deconstruct the calculation into what's causing the supermarkets. And then you know what to work on to get better flow. Make sure the system can be easily updated and maintained. Be careful of getting into logistics that are cumbersome, a huge amount of non-value added activity for really no benefit or very, very little benefit. And make sure you update your supermarkets periodically, okay? Make sure you work the interfaces with other systems, that it ties in with MRP. If you're using work orders, sure, generate work orders on your MRP system, but leave them on the system as planned orders until you get a Kanban. Then you firm the order and release it, okay? Again, and make sure you're using, metrics that are directed toward improving flow and reducing waste. And I just gave you some examples of those, all right? And then you're using those to focus your continuous improvement efforts. If you do that, if you take the steps of quantifying things, primarily quantifying your supermarkets, primarily making sure the logistics are doable, and primarily making sure you have the right metrics, you'll get there eventually. Okay, I'm gonna skip this one because we are done. Anybody have any questions?
Thank you, Don, for a very insightful presentation today. We do have a couple of questions, and I'll read them to you.
Sure.
The first one is, how do you know when to resize the bin sizes?
It's a good question, and I think it's going to be, well, there are some indicators. Okay, let me start with an easy one: seasonality. Okay, if you're in a business that's highly seasonal, you're making something that sells like crazy at Christmas, or making ice cream. Okay, where it's a very capital-intensive business, but you sell 80% of your product in 3 months of the year. You need to resize your bins, your bin quantities. Okay. Periodically, at least several times a year, okay, if not once a month, all right? Or if you're in a like a style business where if you're in clothing or something and you're coming out with new products all the time, you need to resize. Not only do you need to resize bins, you need to redefine what's Kanban and what isn't. Okay. If you have a lot of changes, frequent changes, if you're in high turnover technology where you have frequent changes in your products, you have to recalculate because you may have new items going on Kanban and items coming off. And then the last thing is, if you're making a lot of changes in your processes, in other words, reducing your lead times or reducing your batch size and those kind of things, you want to change the bin sizes, okay? Change the calculation. So those are the kinds of things we look at, seasonality, frequency of changes, and so on. I said earlier that in our experience, most of the clients that we've worked with over the years, when I say most, I mean 90%, recalculate their supermarkets at least once a month. We have some companies we've seen who are using the virtual pull system where there is no physical component to the system. It's what I showed you in the battery company projected on the wall. They resize their Kanbans every night automatically. And they can do that because there are no cards to deal with. So things get redefined and resized dynamically, okay? Almost instantaneously. So
very good.
Yeah. Yeah. So, but if you're using a manual system, you're not going to be able to resize daily because you're not going to be able to keep up with it. But you do need to do it often enough to stay up with changes in your processes and your demand constraints. I hope that answers.
Don, a related question. How do you determine the number of bins to use? You might have answered that in the previous question, but.
Well, I did. I did talk about the calculation of demand during lead time, safety stock, and order quantity, or EPEI. Once you get that number, you divide by the bin quantity, and that's how many bins you need, okay? But I didn't go into detail about the math behind those. I would invite you, we do have articles on our website, you have it in the handout here, that do explain that in more detail. I just couldn't explain it in 50 minutes, okay? But this is why they invented Excel spreadsheets for folks like us, okay? All right? Because if you find your way around an Excel spreadsheet, you can gather data in order to figure that out. But yeah, look on the website. You'll see some articles on how to calculate, specifically how to calculate the supermarkets.
Okay, we've got several more questions. And the next one is, you mentioned Hijunka. How would you implement it in the example you gave?
Which example is that?
It's not clear here. So.
Well, a good question. I actually gave you, I didn't say it, but I actually gave you 2 examples of Hijunka. I gave you I showed you a Hijunka box, okay, where the little green cards are distributed in the box manually. So once you figure out for each item how frequently you could run it, on each resource, that's how frequently you're going to schedule it. And that's going to tell you where to put cards in the Hijunka box. Okay, if I can run it every day, then I'm going to put cards every day. But I also showed you that virtual pool with the battery guys, which that's also has Hijunka built into it because they package the same number of batteries every day. The mix is given to them by what they call their fuel gauge, what that chart showed them, that Gantt chart. So how you execute the Hijunka, and Hijunka is not a very common. It's a common concept, but it's not something we've seen a lot of people do very successfully. Okay, but there's some pretty good literature out there on Hijunka. I think the Lean Institute has some good stuff on pull and Hijunka. It's highly tailored, highly individual on how you set up Hijunka. And I'm not sure what you meant by the example, but I gave you an example of a manual Hijunka box on one of the slides, and I gave you, and you'll see it when you get the handout. You'll see the how it's structured, where you have the part numbers down the on the y-axis down the left side, and then across the top you have the days of the week, or it could be hours in the day if your batches are very small. And the cards, as they come back, the Kanban cards, as they come back from the customer, are distributed day by day in that Hijunka box. So then each day you produce what's in that column. Okay, that's basically how Hijunka is set up. And the time buckets for the columns, whether it's days or hours or shifts or 20-minute intervals or whatever, all depends on the EPEI and the size of the batches in that final assembly process. Okay, I hope that helps.
Very good. I have 4 more questions, Don. The next one is it possible of you to provide an example of a calculation to support a 98% service level?
Yeah, it's easy. It's on the website. Well, you'll see it on the website when you download it. Yeah, it's there. There's a couple things. There's we actually do have a little simulator, a little Excel simulator where you can simulate some calculations. So you'll see that on the website.
All right. Next question. What if your business is all non-repetitive Kanbans? Does Type B Kanban still work? Any tips?
Not only will Type B Kanban still work, it's the only kind that will work. But of course they'll work. One of the examples I showed you where I said the company had reduced their WIP from 1,200 orders to 1,000 and reduced their lead time by 60%. That shop was an engineering prototype shop that had 600 machinists processing 200 orders a week through that shop with an average of 300 operations on a traveler. Okay? Very, very complicated. But they broke it down to just some simple value streams and sort of an overview, a gross overview to control to flow through each of those value streams, and it had a significant impact on their on-time delivery and their lead time through that operation. So absolutely, Type B is the way to handle a strictly make-to-order business. Yes.
Very good.
You can't get more
question.
make-to-order than engineering prototype shop.
Next question. Do you have any guidelines for what should be Kanban and what should not?
Yeah. Well, I gave you some. Basically, the primary guideline is this. If it takes me a week to make something, make a product, but the customer demand, the marketplace, in order for me to take business away from the competition, demands same-day delivery, but it takes me a week to make it. I have to carry inventory of that item or I won't get the business, right? Okay. So if I'm going to carry inventory of an item, I'm going to Kanban it. So there's the primary answer. It's the lead time. Even if the customer orders it twice a year. If I never know when they're going to order it, because a lot of businesses, the customers who order the onesie twosies are the same ones who order the highly repetitive stuff. So I have to be able to service them. So in that case, it's not even a question of frequency, it's a question of lead time. Now, in addition to that, the second criterion is how frequently do I sell it? If I have something I sell very frequently, like every day, I would want to have a supermarket of that. Not that I can't make it every day. I want to have a supermarket of that so that when I do have demand for an odd item, one of the cats and dogs, I have bench capacity in those Kanban items. I can make the special item. Okay? I have the capacity to do it. So it's really those two things. Can I meet the lead time, and is it highly repetitive? I know I'm going to sell some. A quick example, ice cream production. It's an ice cream plant out in the Midwest that during the winter when they're building inventory, they would make all the odd flavors, peanut butter crunch and all that, put them in the freezer. And then in the summer, they make chocolate, vanilla, and strawberry because they're very busy. They can run the high volume stuff. Okay? That was their thinking. And they had it backwards. What they should have been doing is in the winter, you run chocolate, vanilla, and strawberry because you know you can sell that in summer. And then in the summer, you run all the odd stuff, the peanut butter, brickle, and all that. Okay? So that was the case where the repetitive stuff is what you want to carry the supermarket on, and then you make the other stuff either in a smaller supermarket or directly to order. So those are the two things that I would tell you, lead time and how repetitive the demand is.
Okay, another question. Can you give us an example of how a sales organization has or might benefit from a Kanban system?
Oh, boy, that's a good one. Because, after all, who are we doing this for? We're doing this for them, aren't we? I mean, we're doing it for the customer, and the sales are the primary interface with the customer. So I would say probably fewer delays for the salespeople, right? Less indigestion. Now, the value to the sales is you are much more competitive. Your salespeople can go to the customers and offer them deals other people can't. I'll give an example. Once you understand the metrics and you understand the change in metrics, it doesn't that are required, okay, in terms of flow. It shouldn't surprise you to know that there are companies out there who give their customers price discounts. I'm sure you're all familiar with the quantity discount, but they give their customers price discounts if they take smaller batches. Okay? If the customer will agree to take, a blanket order, but take as small a batch as possible. Why would you do that? Well, it makes the demand on your plant very linear, very predictable. Okay? Customers love that. Salespeople love that. So as you improve customer service and you reduce lead times, you have given your salespeople, you've armed them with a huge competitive advantage. All right? So if you're doing something with full systems and it's aggravating the sales department, you're doing something wrong. We're doing it for them primarily. They are driving everything. Okay? So I don't know if that answers the question, but boy, oh boy, and it makes their lives simpler. For example, they shouldn't have to, you're doing full systems correctly. Your sales and marketing people shouldn't have to make trade-offs about whether they're going to get item A or item B. They shouldn't have to go check to see where something is it going to be done in time? That kind of stuff. That goes away. You shouldn't, what you want to do with a full system is eliminate the need to ask those questions in the first place. So then your sales and marketing people can focus on sales and marketing and not expediting and explaining. Okay? I hope that helps.
Very good. Our final question is actually a series of three, but they're all related from the same individual. What data should a Kanban card have? Is an order trigger a Kanban card or just a trigger? And is a Kanban card raised by an order trigger?
Okay, good question. What information should the card have? I think the card needs to have, at a minimum, the part number you want and the quantity you want, okay? The quantity, it's not just the quantity you want, it's the quantity that card authorizes. Because it is now the authorization to produce, not the work order, right? The quantity it authorized. Now, you may want to have some other information. You may want to have who is going to make it. In other words, who's that card go to when I need some more? You may want to have who's the customer of that item. In other words, who gets it when it's done? Where do I send it when it's done? Okay? Minimum, you got to have the item number and the quantity. For a producer and user, it may be that that item runs in a family of products. They run on the same board on a machine. So you may want to have a family designation on the card so that the Kanbans can be grouped by family. What you don't want to have on the card is like a revision number. If you have a lot of engineering changes, you don't want to have. This is one of my favorites. You got to be very careful serializing cards. Card 1 of 6, card 2 of 6, card 3 of 6. Because what happens is, if I need to add 2 Kanbans, it's no longer card 1 of 6, it's card 1 of 8. I have to go change all 6 cards, right? So some things you want to have, must have, part number, quantity. Some things are good to have, supplier and user. Some things you just don't want to do, like serialized cards, okay? Now, triggering, okay? Let's talk about trigger, and I want to talk about it in the context of what I gave you in calculating supermarket. Remember we calculated demand during lead time and safety stock and order quantity. Demand during lead time plus safety stock is the order point, sometimes called a trigger point. In other words, when my inventory drops that level, it triggers the release of an order, or it triggers a Kanban card, or it triggers production or procurement. Okay? So I'm not sure the context in which you're using the word trigger, but what drives the card going back to the supplier is I empty the container. That's it. The card went there. Now, my supplier may have their batch size. I may have 10 parts in a container, okay? Because that's the way they store. I mean, a container weighs 40 pounds and only holds 10 parts, okay? But my supplier's batch size may be 50, because when we calculated EPEI on that press, it came out the batch size was 50. So as those cards go back to that supplier, he gets a card for 10, he's not going to run them. He gets another card, now he has cards for 20, he's not going to run them. He won't run them until he gets 5 cards or 50. So what triggers him to run is not a card, it's a multiple. It's 5 cards. And that's why you have a trigger board or an accumulator like I showed you. So information on the cards, keep it as simple as you can. Be careful that you don't do something that causes you to have to make cards or replace cards all the time. And triggering depends on, is your lot size multiple cards? Is it 1 card? Is it just a 2-bin system and you fill the bin? I hope that answered the question. If it didn't, look, if you have any other questions, or if I didn't hit the point on your question, look, you have my phone number, you have my email. You can, feel free to give me a call or send me an email, and I'll be happy to try to be more specific for you.
Well, thank you again, Don, for a very insightful presentation. This brings our webinar to a close. Our next webinar is scheduled for January 31st, and it will be entitled An Introduction to the Harada Method. Please visit ame.org/webinars for more information and to register. And don't forget to fill out the short survey that will be in your inbox. Thanks, everyone, for attending, and have a productive day.
Thank you.